Okay, we're in week 5, and again, the hope is that you paid attention. You may not have understood everything that was presented to you, but you've paid attention to what was presented to you, and that you need to get example. You need to have examples that that helps you understand what was just presented to you, and that's what we're going to do. Again, we talk about combination and composition of functions. The most difficult things for students to hear is basically the composition. And really, what's difficult for students is that domain range business again, and that can be complicated. But again, the more practice you put in, particularly with prior material, the easier this material becomes. And as you move forward, the easier the courses moving forward will become for you. All right. Now, certainly everyone hits a stopping time where they're going to get something they can't understand. That happens to everyone. We're hoping it's not at this stage of the game now. All right. We've also talked about inverse functions, and that was, I'm going to say a little bit problematic, but we have a visual approach to it. We've talked about what one-to-one is and what invertibility meant. All right. So what we're going to do now is, certainly try to hammer across the points we've made by going through examples with you. All right. And they build. I mean, certainly the first example, not that bad. Second example may be a little more difficult, so forth and so on. Try to pay attention. Try to understand what's being presented to you. However, after you get it presented to you, you still have to go back and study the material. But if there's still a point that needs to be addressed, I want to encourage you to come by during office hours where where I can help you through the material. All right. You can also consider seeing a tutor. I want to be honest with you. Some of the tutors are going to vary in their quality. They may not be expert in this area, and they may give you misleading information. All right. So what I want to do is I'm going to switch to the whiteboard now. Give me 1 second to do so. All right, we're on the whiteboard. And so we're going to do example number 1. And example number 1, you're given a function, f of x. Visually, if I looked at f of x, it's a fairly simple problem. I'll write it down for you. So, f of x, very simple, is 2x minus 3. And some of the questions are, what's the domain of that? Well, A, it's fairly simple. And I'm looking at F. There's no divisions and there's no even roots. So the domain of this is all real numbers. I'm going to use the Blackboard R or the interval notation minus infinity to infinity. All right. Now, again, we're trying to steer you towards interval notation. So I'm going to put a box in this, but you should be aware of this Blackboard notation. All right. It's a Blackboard R. All right. Certainly I would check to make sure that what this is here is the same thing as what they say in the answer key is. All right. Let's go to the next question. Next question, what's the domain of G? Well, let me write down G. G is, and it's 3x squared plus 2x minus 5, and this is B. And certainly, I'm looking at it, I don't see any divisions, nor do I see any even roots. So at this level again, we're going to say all real numbers again. Again, that's a Blackboard R. We prefer the intervals, though. We're just saying all the numbers come in. Now, when we say that, we're saying the x's are that. All right, so I'm going to check my k, and I feel pretty good about that. All right, what's the next one going to be? What's f plus j? Well, that should be simple. The other question is, what's its domain? The domain of f plus j, let me write this down for you. This is going to be c, f of x plus g of x. Be careful to write this down. F of x is 2x minus 3. Plus, well, g of x is 3x squared plus 2x minus 5. Now, you're expected to add that together and put in proper order. 3x squared. Let's see, 2x and 2x is 4x. And minus 3 minus 5 is minus 8. So I'm going to say that's what f plus g is. What's a domain? Well, it's going to be easy because it's just the intersection of those sets. And where do those sets intersect? Everywhere. So the domain of that is going to be all real numbers. Again, my recommendation to you is, look at the k, and I'm looking at c, and I see 3x squared plus 4x minus 8, and I see minus infinity, just as we had put it over here. All right, let's go to the next one. And again, we're hoping it's not confusing to you, but it's, for some students, it is confusing. Right? You're looking and say, what do you want me to do now? Well, we want you to take f of x minus g of x. I'll write that down for you. That's d. And subtraction is commutative. I'm sorry, subtraction is not commutative. I'm sorry, I said that. So let's see, D, whoops, I'm gonna go back to white. And D again is f of x minus g of x. Well, I'll write this down. So it's gonna be 2x minus 3, that's what f of x is, minus g of x. What's g of x? 3x squared plus 2x minus 5. Well, I'm going to write down in order, and looking at it, it's, minus 3x squared. 2x minus 2x, there's no x's. Minus 3 minus a minus 5 is plus 2. Right? You could also write this in a different order. You could write down as 2 minus 3x squared. Right? Both answers are completely acceptable. All right? I'm looking at it though, and I'm going to say this one looks better to me. So someone says, what's really proper over polynomials? Well, either ascending order or descending order, depending. Later on, you're going to be writing things in ascending order where the powers are going up. But right now, either one is fine by me. What's the domain of this thing? It's the intersection of the two sets. What's it going to be? Minus infinity up to infinity. That's where the two sets intersect. All right, let's get a red ink out. And again, I want to point out answers are provided to you, and for good reason. We want to make sure you're looking at those answers and make sure you can agree with those. If you can't, though, there has to be something wrong with it. All right, let's go to the next question. And the next question, I'm going to pull it over here. I have some memory of what I'm doing. And I'm seeing f of x times g of x. I'll write that down for you. This is letter E now. They want f of x times g of x. And what's that going to be? I'll push this over a little tiny bit. All right. Well, what's f of x? F of x is 2x minus 3. Again, if you can't remember that, just read back over your notes. And what's g of x? It's 3x squared plus 2x minus 5. Now, granted, I have no objection to putting that down for an answer, but other people do. So what I want to go through was the multiplication for you. And what do you get when you multiply that out? And again, I have no objection to this answer. I want to go through the multiplication because that's typically what most other people want you to do. All right, that's 6x cubed plus 4x squared minus 10x. That was distributive property multiplication. I distribute the 2x across the three terms. Now I'm going to do the minus 3. What do you get? Minus 9x squared minus 6x plus 15. Combine the terms. What do you get over here? At like terms, 6x cubed minus 5x squared minus 16x plus 15. Now, someone says, what's wrong with doing that? I mean, it was pretty easy to do. There could be an error. All right. Now, what am I looking for now? I'm looking for the intersections of f and g, their domains, where they intersect all the real numbers. Let's look at our key. And I'm looking at this in the key. I'm seeing the 2x minus 3, 3x squared plus 2x minus 5. And I see the expansion. Let me just make sure I'm seeing 6x cubed minus 5x squared minus 16x plus 15. I definitely see that. I see that. And I see the intersection of those two sets, which would be minus infinity to infinity. All right, let's go to the next one. And the next one is letter F. And what does F want me to do? Well, they want me to take f of x and divide it by g of x. All right. Again, if you can't remember what the functions are, all I can say is, go back and look. Right. I have some memory. I'm not saying it's great memory, but f of x was 2x minus 3, and g of x was 3x squared plus 2x minus 5. Now, again, I don't mind that answer. To me, it's a good answer. Now, someone says, could you do something with that? You could try. I'm going to point out what you could try to do, like what you did in basic algebra. You factor top and bottom with the hope there'd be a cancellation. Let's see, 3x and x. I guess I do 5 and 1, right? And let's see, plus minus. Let's see if that works. If it doesn't, I'm going to change it though. Basically I would say, for a lower level class, I would say at least try 3 times. What do you get? 3x squared? Well, that looked pretty nice. 3x minus 5x. Oh, I made a mistake. I'm going to make my erasure. I notice it right away. I'm not saying that's right either. I'm going to check it. 3x times x is 3x squared. Then you get you get minus 3x plus 5x, which is plus 2x, and you do get minus 5. So this is also a good answer. Now, what's a domain? The domain is still the intersection of those two sets. However, I have to remove any cases of division by 0. And where did you get a division by 0? Well, at 1, so x can't be 1, and x can't be, the other 0 would be minus 5/3. We like to write this in intervals. I'll go through that with you. That's minus infinity up to minus 5/3. We'll check the key later. Union minus 5/3 up to 1. Union 1 up to infinity. And those numbers 1 and minus 5/3 are not being touched. All right, I'll look at my key and see how I did. And I'm seeing the 2x minus 3. And I'm seeing the bottom 3x squared plus 2x minus 5. By the way, this answer is not written down, but you could write this one down too. It's really the same answer. Let's see if we got the domain down. You know, minus infinity to minus 5/3, union minus 5/3 to 1, union 1 to infinity. Yep, I got that too. All right, let's keep going. Yeah, I know so sometimes it seems like really a lot of busy work over here. And we're going to do this one over here. And this is the letter G now. All right, what's letter G? They want g of x over f of x. Well, again, I have some memory, and g of x was, but again, if you don't look back in the notes, you'll see what g of x is. It's 3x squared plus 2x minus 5 all over 2x minus 3. I like the answer. It's a fine answer. If you want, you can rewrite it a little differently, and you could write that in the factorization at top. We just did that. I'm sure you recall that. Really not changing the problem at all. But what do you get over there? 3x and x. Let's see, 1 and 5. And again, if you can remember, fine. If you can't, just check it again. That's 3x squared minus 3x plus 5x is 2x. Yeah, it looks pretty good. That's a good answer too. What's a domain? Well, again, it's all the real numbers. That's the intersection of the two sets. However, you got to start to realize there's a number that's bad news. And what is that number? If the bottom becomes 0. And when does the bottom become 0? 3/2. Let's write it as an interval. That's minus infinity up to 3/2, union 3/2 up to infinity. Again, I'm going to look at the answer key. And when I'm looking at the answer key, I want to make sure that you're getting the same answer. And let me put this over here. I'm going to squeeze this down a little bit. And let's take a look at it. And let's see if we got it. So I'm looking at this. That's 3x squared plus 2x minus 5 over 2x minus 3. Gee, I did that pretty good. And did I get the domain right? Minus 5 to 3/2 and then 3/2 to infinity. That looks pretty good. All right. Let's go to the next question. And this is number 2. All right. So I'm going to pull this on the side. And let me do that for you. I need a lot of room for these problems, don't I? I'll pull it on the side. Push this up here. And I'm going to blow it up. And I'm going to read it. It's got f of x, and it's got g of x. And they want me to find each of the following. And it really doesn't look that bad to me. So I'm going to write A down for you. And what's A? A is what's the domain? Oh, I got the red ink again. Let me go backwards. So it's the domain. What's the domain of f? Well, let's write f down. And what's that going to be? The root of 4 minus x squared. All right, so what's the domain of that? Well, it's an even root. So the radicand 4 minus x squared must be greater than or equal to 0. And I'm hoping you're getting better at this, including you can look at that and answer the question. I am going to write this down though for the students who are not that level yet. And you may not be at that level yet because you haven't practiced enough. Minus 2 and 2. This goes back to really the first class. I'm going to look between minus 2 and 2, and I would pick 0. And if you pick 0, the test value would be positive times positive, which would be positive. That's certainly greater than 0. And, minus 2 satisfies it because it makes it equal 0, and 2 satisfies it. So the domain is minus 2 to 2. That's a domain. A is done. Let's go to B. Before I do that, though, I want to point out these answers are clearly specified for you. Let's go to B. What does B say? What's the domain of G? Well, let's write down what G is. G is an even root problem. And what's even root? 1 minus x. Well, what I need to know about even roots, the radicand, 1 minus x, must be greater than or equal to 0. Well, this is a linear inequality, super simple to solve. It's what you solved in Math 100. So I'll put this down, 1. X could be equal to 1. And what else can x be? It's less than 1. All right, so what's the domain now? Minus infinity up to 1, and it touches it. Again, I want F size. Look at the key. It should be fairly easy to do that. All right, let's keep going. And it certainly, C doesn't look bad to me. C says, can you take F and add it to G? And I can. And what would you get over there? Well, again, if you can't remember, look back up. What's F? Square root 4 minus x squared plus the root of 1 minus x. All right, get your red pen out. See if you got that answer. And I'm seeing that, and I'm seeing that. Now I want to go through the domain with you. And as I do that, if you're quick at this, please do not think you have to slow yourself down. You just simply go forward. But it's the intersection of the two sets. So I'm going to put the two sets down for you. And I'll talk about what intersection means in a second. Minus 2 and 2. And the other guy is going to be from 1. And I'll put this on another line. And 1, if I'm going to line these things up, 1's about here. And then it goes like this. Okay, where do those two sets intersect? And what I mean by that is what do they have in common? Well, they have things in common. What do they have in common? Well, from minus 2 inclusive up to 1 inclusive. So that would be the domain of it. Again, get your red pen out and make sure you got that as an answer over there. We do. All right, let's go to D. And D is going to be, certainly related to this one over here. And it's pretty easy to write down. So let's write D down. And what is D? Well, D, if you look at it, it says f of x minus g of x. Well, this is easy. What's f of x? It's the root of 4 minus x squared minus, well, what's g of x? It's the root of 1 minus x. What's the domain? It's the intersection of those two sets. Well, we've already done that. And what's that going to be? Minus 2 to 1. Let's get our red ink out, see how we did. And I'm seeing both of those. Let's make sure of that. Yep, I did a pretty good job in that. All right, let's go to the next one, which is going to be f times g. And we'll look at the key later. Again, I'm looking at problem E now. All right. E is f of x times g of x. Well, what's f of x? It's the root of 4 minus x squared. And what's g of x? It's the root of 1 minus x. What's a domain? It's the intersection of those two sets. And we've already done that. Not multiple, we did it once. We're just reusing it. All right. Let's look at our key. And I want to make sure it's in there. If it's not, it's something wrong. And I'm seeing it. I'm seeing both of those. All right, let's keep going. And I'm going to move over here. And I'm going to do F now. And what's F? F is f of x over g of x. All right, what's f of x? F of x is the square root, 4 minus x squared. And g of x is going to be 1 minus x. What's it going to be? It's still going to be the intersection of the sets, but we need to remove a value from it. And what value do we need to remove from it? The number 1, because of division by 0. So I'm hoping you remember that the intersection of sets was minus 2 to 1, but I need to remove the 1 because the 1 would cause a division by 0. So to remove the 1, all I have to do is, let me erase this over here, put that parentheses instead, and this will be the domain of it. Now, I understand that some students may be upset with the radical in the bottom. You have to understand something. As you move forward in mathematics, we're not so upset with the denominator being a radical. But if you went back to Math 100, your teachers would have said, oh, you have to do this instead. And I would say it really doesn't add much to problem. But if you feel possessed to do such a thing, please just do it. What do you get over here? 4 minus x squared times root 1 minus x. On bottom, you get 1 minus x. My claim over here is it really made it look worse to me. So that's why I don't want to go in that direction, right? I'm going to erase that. But again, if you did that, I wouldn't grade it wrong. I'd say good for you. All right, you listen to your Math 100 teachers. All right. What I want to do now is look at the answer key. I want to see what's in the answer key and make sure I got it right. And I'm seeing it right over here. All right. Let's go to the next question, which is letter G. And letter G says, take G and divide it by F. Again, you would have to know what G is, and G is the root of 1 minus x, and you would have to know what F is, and F was the root of 4 minus x squared. Well, it's still going to be the intersection, but there's a problematic number. What's problematic number? When does the bottom become 0? Well, at minus 2. So what I have to do is I have to remove it. I got to remove that minus 2. How do I do that? I exclude it. All right. So this would be the answer, both the function, that's a division or a quotient, and its domain. Let's take a look at the key. I'm seeing this, and I'm seeing this. All right. What problem is that? Problem number 2. All right. So again, it's so much work. I don't think I could get through that. Well, take it in pieces. But at some point, you got to be able to move a little bit faster. It's not a speed contest, though. Try to learn the material. We're going to the next page, and we'll go to problem number 3 now. All right. So I'm seeing number 3. And I'm going to, certainly look at number 3. And number 3, slightly more difficult question because you're asking for domain and the range. So let's go through this one step at a time. So number 3, and I'm going to put this down here for you. I'm going to write the two functions down, f of x, x squared minus 1. I want to draw a little, I always say like a simple picture. And this thing would look like this. It's a parabola. It's not so bad. We've had some experience with graphing. And by looking at it, I could say the domain of this thing is all the real numbers. This has no even roots or divisions. And the range of this, I'm looking at the picture, and the range, the vertex occurs, the range is the y values, minus 1, and it touches it, and then it streams off to infinity. And again, I'll put the answers down later, all right? Let's go to G. And someone says, oh, G is going to be a tough one. And again, we're hoping you're getting more experience with this. All right, so the domain of that, I would write down a little more complicated than the other one, because it's an even root. This has to be true. And what does that mean? The radicand has to be greater than or equal to 0. So again, if you're quick at it, that's fine. If you're not, take your time. I'll put a number line down. We're looking for domain, a little more involved. Take a number in between minus 1 and 1, like 0, plug it in. You get a positive number. Certainly that satisfies that inequality. Minus 1 satisfies it, and 1 satisfies it. So the domain of this guy over here is going to be between minus 1 and 1. And the range is saying, I'm going to say you need a graph for that. All right. So I'm going to put a graph down. I know the graph starts at minus 1 and it stops at 1. This is somewhat familiar to me. It should be familiar to you as well. All right. I know it's 0 there. If you plug this in, you get 0. I pick a number in between that. What number in between that would be good to pick? I don't know, maybe 0. Plug it in, you get 1. This up here is the 0.01. This point over here is 1, 0. This point over here is minus 1, 0. Well, hoping you're starting to realize there is a connection between those 3 points, and the square root's got to be positive, and the connection between these is actually a semicircle. All right. So I now know the range of it, and again, it's the y values. The least it could be is 0, and then it goes up to the number 1. All right. So let's see what the questions are, and I'll see if I got them right. All right. So what was A? A was, what's the domain of F? Well, I said it's all real numbers. Whoops, let's get it ready. I feel good about that. Now, what did they say? What's the domain of G? And this is G's domain. Well, I agree with them, and that's good news. Then the next question, C, we're just doing one question at a time. It says, what's the range of F? And I said it's -1 to infinity. We're in agreement. And then they said, what's the range of G? And we're in agreement. I mean, we've got the same answers. Here comes where a lot of students get confused, and we're not trying to confuse you, right? This is not what we're trying to do, right? So I'm going to put down what they want me to do now. Whoops. They want me to do F of G. No, that's not fog. It's F of G. I'm going to write this down for you. I'm going to post this over here. We'll look at the key later. What does this mean to me? F of G. Then someone says, what's G? I'll write it down for you. So it's going to be F of G. What's G? It's the root of 1 minus x squared. All right. Now, what does F do to its argument? It squares it, and then it subtracts 1. Well, let's write that down. And again, if you square that radical, you would get 1 minus x squared minus 1. What answer do you get? Minus x squared. Now, I'd say most students can do that pretty readily. What they have a hard time with, though, is this. And I'll go through it with you. All right, so what's G letting in? Now, G's the gatekeeper. What does G let in? Well, you'd have to know its domain for G is -1 to 1. All right, that's who's allowed in. Now, once G takes those numbers, it spits numbers out to F. And the big question is, can F accept those numbers? Before we do that, though, what numbers does G spit out? G spits out the numbers 0 to 1. Here's the deal. Can F accept those numbers? Well, F can accept any number in the universe. It has no troubles with that. So what's the domain of this problem over here? Well, what was allowed in? Let me go back to white. -1 to 1. Okay. All right, I want to go to the key. And I'm trying to emphasize that you also should be going to the key to see if you got it right. And what do they get? Minus x squared -1 to 1. This is good. All right, we're doing all right. All right, let's go to the next one. And someone said, what's the next one? Very similar. The next one is what's G of F? All right, blow this up. And again, we'll look at the key later. Well, this is G of F. My understanding is what's F? And if I can't remember, you'd have to look it back up, but it's written on my paper over here. So this is going to be G of x squared -1. All right, generally speaking, most students can do this pretty readily. Then the question is, what does G do to the argument? Well, it's a root of 1. I think I might have copied something. Oh, no, I didn't. I'm sorry. Minus this thing here squared. That's what G does to it. I realize some students said, do I really need to do that? Let me just see. I think I can. You would get 1 minus, well, if you squared x squared -1, you would get x4 minus 2x squared plus 1. Keep going. What would this give me? Let's see. 2x squared minus x4. All right, I guess that's what the function is now. Here comes the tough part, and it is tough. I'm not saying it's not tough. All right, it's not, for a lot of students, it's just impossible. So, but I'm going to say, even though I might have said for some students it's impossible, you should still try. All right, so let's take a look at this. Who's F letting in? Right, you'd have to know that. F lets everybody in. Then what does F do? It tries to spit out numbers to G. And what numbers does he try to spit back at G? -1 to infinity. Question is, can G accept it? And G cannot accept it. And why is that? If you look at it, what can G accept? Only between -1 and 1, right? only between -1 and 1. So what I have to do now, right, is I've got to figure out how could I have f only spit those numbers out? And I'm going to write this down for you. So g can only accept the numbers between -1 and 1. That's what we can accept. And who's trying to give him the numbers f? And who's f? It's x squared. And I know this is difficult, -1. Now, certainly I'm looking at it and you might say it's too difficult to solve. At least you wrote something down though. What I'm going to do is add 1 to all sides. And what would you get? 0, x squared, and 2. All right. Now, I hope you realize that no matter what x I choose, it would be greater than or equal to 0. No matter what x, 0, 1, a billion, minus a billion. But I'm wondering what values of x when squared would be less than or equal to 2. And I'll write that down. So really what I'm looking to do is I'm looking to say, when is x squared less than or equal to 2? Well, I know that's difficult, but I'm going to do what I did in the past, right? Get it to 0. Put the zeros down. You may wonder I'm not factoring. You could, but it doesn't look much better when you do that. And that'll be between minus root 2 and root 2. Hope I didn't go too fast with that. Take a test value between minus root 2 and root 2 and 0, plug it in. Negative numbers are definitely less than 0. Again, I have an ability to solve an inequality. If I plugged in minus root 2, it becomes 0. That satisfies it, and root 2 satisfies it. So I now know the domain. And what's the domain going to be? Of the real numbers that we let in, only between minus root 2 and root 2 are going to come in. All right, I'm going to go back to the answer key. And I want to emphasize the answer key is written down for you. Now, someone's going to say, you got a funny looking answer over there. Well, I do have this one. I do see that. And I have the other one. All right. I want to go through why they wrote another one down there. And again, it may confuse you. And again, the point of being confused is you're going to try to remove the confusion. But I'm claiming over here, I'm claiming this. I'm claiming that this thing over here can be rewritten. And I'll go through that with you. So what are you going to do? Well, I'm going to factor the radicand. And if you factor radicand, you get x squared. And that would be 2 minus x squared. All right. Then I want to emphasize to you that this may seem strange to you, but a lot of people actually believe the square root of x squared is equal to x. And this is simply not true. The square root of x squared is equal to the absolute value of x. Now, what I would recommend you do over here is try to graph both of these out using a calculator or a computer algebra system. In other words, graph out the square root of x squared and graph out the absolute value of x, and they're going to look identical. All right, they will look identical. I'll claim this though, the square root of x squared will not look the same as x if you graph those out. It just doesn't happen. All right, so what do they do over here? And they write the square root of x squared as the absolute value of x, and this would be 2 minus x squared. I want to just emphasize that over here. I do see that written up here. All right, let's go to the next page. And we're going to be doing number 4 now. All right, so number 4, I'm thankful for what they've given for number 4, but I'll read through it, and as I read through these problems, I'm hoping you're taking the time and thinking about what you're reading. It says, given f of x and g of x, answer each of the following questions. Now, I want to emphasize that they gave me a picture, right, of f, and I'm going to use it, all right? So what I want to do is, I know what f of x is, and I'll write this down for you. F of x, f of x is 3 over x squared minus 1. Well, I think I can write the domain down pretty easily for this. And what's that going to be? All the real numbers except x can't be plus or minus 1. So I'm going to write that down in interval notation. That's minus infinity up to -1, union, -1 to 1, union, 1 to infinity. And that's a domain in interval notation. And yeah, they're going to ask that question. And we'll show you where the answer is later. What's the range of this? This is the whole point of having a picture. I realize pictures can be deceptive, but it's nice if you can look at a picture. And I'm seeing the picture over here. And I want to point out what I'm seeing over here. I'm seeing this portion of the curve. And I'm seeing this portion of the curve over here. I'm not saying it's the best picture in the world, but it's a picture nonetheless. And I'm just tracing over the picture there. It's a crappy looking trace job though. So my question over here, what's the domain of that? Well, I'm looking at it and I'm going to say, well, it's streaming off to the bottom to minus infinity. And then it kind of peaks out. And I'm going to say it looks like -3. And -3, I want to point out, it's really, it's the y-intercept, and that certainly makes sense. If you put x to be 0, you would get the number -3. Here comes where the trouble is. It's union. I want to tell you, though, it's never going to equal 0. Someone says, well, how do you know that? Just look at the function. It's 3 divided by a number. Now, 3 divided by a number, what do I know about that? I know it could never be equal to 0. For a fraction to be 0, the top would be 0, and 3 is never equal to 0. And then what does it do? Never touches 0, but goes off to infinity. It may require some thinking, and I'm going to encourage you to think if you can. All right, let's go to the answer key. And again, the reason I want to do that is I want to see if I've done that correct. All right, so what's A, the domain of F? Well, we just did that, and we got this over here. All right, make sure you're looking at that and you're agreeing with that. I wrote down the same thing. Okay, I want to point out they also asked for the range of F. What did I say it's going to be? That's letter C. I said this. Did I say that over there? -3 to -3, union. Yep, this is good news. All right, now someone's going to say, do I need to remember that? Well, it's written down now. There's no real need to memorize this anymore. You have it written down, and that's why we write things down, so I have to remember them. All right, let's go to the next one, and the next one is going to be g of x. All right, so I'll write g of x down for you. And g of x is a line, and what's that line going to be? X plus 1. What's the domain of that thing? Well, there's no even roots, there's no divisions, all real numbers. That's -infinity to infinity. What's the range of that? It's a line, and I really mean that. It's a line that goes on forever in each direction. What's the range of that? -infinity to infinity. Let me go to the answer key and see if I did a good job. And I'm going to look at it, and I'm seeing it right here and right here. All right, that's good. All right. Okay, let's keep going. And what I mean by keep going, I really want to be very careful about what they've asked me to do. I've done these 4 items over here. What I want to do now, and I'll go over here. Yeah, maybe not, I'll do it over here. They want to do f of g. I'll write that down for you. F of g. What does that mean to me? F of g. Someone said, I don't even remember what g is. Well, it's written down, so I'll write it down for you. It's f of, what's g? X plus 1. And again, if you can't remember, look back. You'll see it. It's written down. What is f? It's 3 divided by 1 minus the argument squared. Well, I want to do that for you. And what do you get over here? 3. This should be 1 minus, if you took x plus 1 and squared it, you get x squared plus 2x plus 1. I want to simplify that. That would be 3. The bottom would be minus x squared minus 2x, and 1 minus 1 is none. I don't like the way that looks, so I'm going to write down as -3. I'm multiplying top bottom by -1 over x squared plus 2x. All right. Now, again, before I look at the answer key, I want to do this domain business for you. And then the question becomes is, who does G let in? Everyone. Who does G spit out? Everyone. Can F handle it? Well, I hope you realize that F can handle it. So what numbers can he handle? He can handle any number you hand it except plus or minus 1. So what I now need to do is worry about, when does G give me plus or minus 1? I can't let that happen, because if G gives me plus or minus 1 and he feeds it to F, F is going to choke on it, and we don't want that to happen. So I just said X plus 1 equals 1. Well, that's easy. I'm going to say X can't be 0. And why is that? If X were 0, it would feed back a 1 to F, and F can't have that. And X plus 1 can't be minus 1. When would that occur? When X is minus 2. So I'm going to say the domain of this guy over here is, and again, looking back, it's all the real numbers are coming in, but I got to exclude 2 numbers now. So it's all the real numbers, but I can't let in 0, and I can't let in minus 2. Let's write that down. Minus infinity up to minus 2, union, minus 2 up to 0, union, 0 to infinity. I'm not beyond make a mistake, by the way. I mean, it's not misunderstand, misread, whatever. I want to go back to the key. And someone says, why do you want to go back to the key? I want to see if I got the right answer. So I'm looking at it, and I think I made a mistake somewhere. Not in the domain, though. And I got to see, where did I make a mistake? And I got to look back over it. Because I wrote down minus 3, and they have 3 written down. Maybe my key's wrong. I would never assume something's wrong until I go through the work. Now, let me see if I did that. Yeah, you know what I did? I thought I remembered G when I didn't. I got to erase this now, and I apologize. All right. And that I hate to say, this is me working from memory, and that's never good. All right. For me anyway, I'm a lot older than you guys. And I wrote the wrong thing down. That wasn't what it was. What was it? It was the argument squared. Whoops, sorry about that. It was the argument squared minus 1. I got to erase the next one up there. I'm glad I looked. I'm glad I made a mistake. My mistake was I was depending on memory, and my memory shot. Couldn't remember correctly. Let's keep erasing all the problems. Let's over to get erased again. And what would that be? Well, let's write down. It's going to be, let's see, x squared plus 2x. And I'll put a box this one over here. This one over here was an error. I'm glad I looked at the key. And you should be looking at key too when you're doing homework. All right, let's go back. We'll look at the key and see how we did. And I'm looking at it. I know it's tough to do that, by the way. And let's just take a look. I'm seeing this, and I'm seeing that domain business. All right. All right, let's keep going. I want to do G of F now. All right, G of F. I'll try to do better this time. G of F of X. What does this mean? G composed with F. And what's F? Well, I'll write it down for you. F was 3x squared minus 1. Yeah, I'm using my memory again. And then the question is, what does G do to its argument? All right, and let's go back. I want to point out that you know about G. And what's G? G takes the argument and add 1 to it. So I'll put that down for you. It takes the argument and adds 1 to it. Now someone's gonna say, can I just box that? Yeah, you can, but I want to do a little bit of work, right? Common denominator, x squared minus 1. Then I would get 3 plus x squared minus 1, which would give me x squared plus 2 over x squared minus 1. All right, I'm going to do domain and range now. I'm sorry, I misspoke. Domain, because they did ask about the domain of this thing. And this is the part where I should say, I can't remember. what you're doing over here. Then the big question is, who does F let in? Who is F letting in? And again, you may not be able to remember that, but it's really not that bad. We did that in the beginning. And who does he let in? Minus infinity, comma, up to -3, union 0 to infinity. You know what? I just did it again. I'm not thinking, and I apologize. And this is something that I really need to start to concentrate on more. I need to think. And again, I was looking, but I wasn't reading correctly, not even thinking. And the domain of this guy over here, again, I apologize. I'm looking at it. I wrote the range down, but the domain of this guy is minus infinity up to -1, union -1 up to 1, union 1 to infinity. All right. And then F tries to give G somebody. What does he try to give? Well, minus infinity to -3, union 0 to infinity. Now the question becomes, can G handle it? G can handle any number. So now I know the domain. And what's a domain? It's who's coming in. Who's coming in? These guys are coming in. So let's write that down, and we'll look at the key later. So the domain of this guy is going to be minus infinity to -1, union -1 to 1, union 1 to infinity. All right. So let me look at my answer key. And again, I know it's difficult to do that, but I'm going to encourage it. I really mean that. So I got this, x squared plus 2 on top, x squared minus 1 on the bottom. And I have this, minus infinity to -1, -1 to 1, union 1 to infinity. I feel really good about that. All right, let's go to number 5. And we'll go to number 5 and 6 now. I'm going to move these things around a little bit. And I want to do number 5 for you. All right. Now, number 5, less involved. The other questions were more involved, domain and range thing. But they want me to verify this is a one-to-one function. And I'm not going to say there's only one way to do something, but what I'm going to claim over here is that for me to verify this is one-to-one, what I want to do is I want to plot it. And then we'll talk about what that means. If you're going to plot it, what would you get? Well, I'd probably take one really simple point over here. And the point I would pick, believe it or not, would be, let's see, I would probably pick 0 for x, and I would get -1 for y. All right. But so it says, what other point would you pick? I would probably pick 1 for x, and what would I get for y? 1. I now know the picture. It's a line. And it looks like this. Okay. Definitely functional. Passes the vertical line test. How do I know it's one-to-one? I'm going to use what's called the horizontal line test. Okay. So horizontal line test. What am I saying over here? I'm looking for a horizontal line that hits it more than once, and I can't find any. All horizontal lines, no matter where I draw them, is going to hit this once. All horizontal lines hit once. So what I'm going to say, by the horizontal line test, this is definitely a one-to-one function. Let me read the solution to you. It's in blue. It says work will be done in class. Well, we're doing it at the whiteboard. But if we're in the class, I'll still be doing it at the board, by the way. Make sure you take notes. I would say you probably should take notes, all right? Or get notes from a reliable classmate. I say this a lot in the notes, but I'll be honest with you, it's really tough to find someone you can rely upon. And the best person to rely upon is yourself. Be prepared, all right? Let's say doing a graph here is sufficient to show the function one-to-one. That is, pass the horizontal line test. I feel pretty good about that. Let's go to the next question. Next question says, given f of x equals, it seems like the same question. They want me to do domain, range, and inverse. Well, I'm going to write this down for you. It's going to be a really simple question, all right? So let me point out what I got over here. F of x equals 2x minus 1. Its domain, minus infinity to infinity. No divisions, no even root problems. Its range, well, we just did its graph. It's minus infinity to infinity. I'm not going to find its inverse. Before I do that though, I want to emphasize to you, we call it F inverse, we don't know it yet. The range, I'm sorry, I didn't mean to put that down. The domain and range can be written down now. And let me tell you why. An inverse is basically just a rotation about x equals y. So really what am I saying over here? This domain now would be the range if I'm rotating. This range would be the domain if I was rotating. So let's write that down. Might be hard to get this one wrong. All right, let's go through the work. What's the work? And it's written in your notes, by the way, we've covered this in class. Change f of x to y. Interchange x and y. Solve for y. We're done. All right, I'm going to go to the key, and I want to see how we did. All right, so we're looking at the key. Did I get the inverse right? This is the inverse. Pretty good. All right, domain and range of it, I've got that written over here. You can read through that. Simple problem. I also want to point out they did a really nice graph. Someone says, why do they do a graph for me? They want you to do a graph. I'm going to write down what the functions are though, all right? The blue guy is the F inverse function. What was F inverse? Just to remind you, x plus 1 over 2. If you were to graph that, I would say a good point to pick would be -1 for x, you get 0. What's another really easy point to pick? 1. 1 plus 1 is 2. 2 divided by 2 would be 1. This looks really nice. This is the blue curve now. All right. What's the other curve they drew? And it's in black. 1 second. I'll do it in green. What's f of x? 2x minus 1. I'll put that down for you. All right, let's plot it out. What's a nice easy point to pick? X to be 0, you get -1. Another easy point to pick would be x is 2. 2 minus 1 is 1. Okay, there's another line there. I want to put on what that line is. It's this thing over here. It's a dashed line. I'm hoping by providing you good graphs that you've got a really good idea. If you have a good graph, it's giving you information. This line x equals y. What do I notice about this? The blue and green curves, or lines I should say in this case over here, are simply just a reflection about the line x equals y. If you went back to that topic on symmetry we were talking about, this was one of the symmetries we look for. It's indicating invertibility, all right? That F and F inverse are inverse of one another, all right? You should observe that symmetry, all right? It's a nice symmetry to observe. All right, that was number, what number was that? Number 6, we can go to number 7 now. All right, so let's see, this is number 7 here. The next page, because there's probably a picture there for me. And I'll go through it. All right, I'm gonna go through number 7 now. All right, let me write this down for you. And number 7 is, it's f of x. And yeah, I know it's difficult. It's a more difficult problem, by the way. What's f of x? It's the cube root of x cubed minus 1. I'm hoping that you're getting better at domain though. So looking at this thing, I'm not saying it's the easiest thing in the world to do. I'm sorry, it's x cubed plus 1. It's not the easiest thing in the world to do, but you should realize that argument has got to be greater than or equal 0. So it's going to start at -1. That's where it becomes 0, and it goes off to infinity. And the range of this guy over here, again, even out of the picture, I hope you realize that the square root function, well, it's going to start at 0 because if I plug in -1, I'd get a 0. It starts there, but the square root function returns positive values. All right. If someone says, is that important to know? It's critically important to know. And the reason for that is, although I don't know its inverse, I do know its domain and range. I'm sorry, I shouldn't put the equal sign there. Sorry about that. Okay. The domain of the inverse is the range of the function. And what's that going to be? Oh, that's going to be simpler. It's 0 to infinity. We'll look at the picture later. What's the range of it? It's the domain of the other guy. So it's going to be -1 to infinity. Okay, we provide a key to you. We'll look at the key later. But right now, what I want to do is I want to find the inverse. All right, so what's the inverse going to be? I'll write this down for you. Change f of x to y. Interchange x with y and y with x. Solve for y. Square both sides. I'm going to add 1 to both sides. And I can take the cube root of both sides now. And so y would be equal to the cube root of x squared plus 1. And that's the inverse. Let's write that down. So it's the cube root x squared plus 1. Now, certainly, I do want to look at the k. All right, so why do you want to look? I want to see if I got it right. Maybe I made a mistake. So let's see if we got this right. And I'm going to say that, did I get the inverse right? And I did. It's right over here. It says cube root of x squared minus, wait a second. Oh, I made another copy error. Oh, I got to correct it. Let's correct it now. I made a copy error. And I think my copy errors really come from me not thinking. So I want to point out, I have this written here, and what I put over there, that's crazy. It's supposed to be plus. Let me get my eraser out. Got to erase that now. I'll do that for you. Erase this over here. Erase this over here. All right, let's go back to my grading. So let's see, did I get the correct inverse? And it's the cube root of x squared minus 1. Did a good job. I want to see if I did the domain and range right. And I'm saying since first off, we know that f is a one-to-one function. Well, if they're asking me to find an inverse, I'm just going to assume that. It talks about the domain of it being greater than or equal to -1, the range being greater than or equal to 0. I got that covered. I'm just reading. And I'm glad I read that because that's what they said. And that's really a good thing. Let's look at the picture. All right, let's look at that picture. All right, we'll talk about it one step at a time. And, you know, what's the blue portion? I want to point out the blue portion is that inverse. And I'll write that down for you. So this blue curve here, F, oops, sorry about that. F inverse is the blue portion, and the blue portion is the cube root of x squared minus 1. Okay, let's go through that. If you were to graph that guy out, you know, certainly I know the domain and range of it, but point-wise, you know, I'd probably pick, you know, 0 for x. And if I did that, what would I get? And I'm not saying it's easy to graph these things. It made me want to use a machine. I'm not opposed to using machines. Maybe it's 0, you get -1. All right, then the other number I pick, I'd probably pick, I don't know, x to be 1, and I'd get 0. Now, certainly there's many other easy points, but I'm hoping you can basically buy into this thing over here. All right, what's this little red dash line here? And again, we're hoping you're looking at the good pictures we provide you. We hope you're going to learn from those pictures. That's the line y equals x. What's the other guy going to be? It's the actual function f. And what's f? I want to remind you, it's the cube root of, the square root of x cubed plus 1. I'm going to put that in green. Okay. All right. First point I'd pick is probably -1. That would give me a 0. Next point I'd pick is 0. And the curve would look like this over here. Again, you might have to use a machine to do that. Okay. I'm going to write points down for you though. And I want to write the points down because I want to show you what happens to these points over here. What's this point over here? -1, 0. What's this point over here? 0, -1. I hope you see the reflection now, right? X becomes Y, Y becomes X. -1, 0 becomes 0, -1. Let's do the next point. What's this point over here? Well, that's going to be 1, 0. What's this point over here? It's 0, 1. I'm hoping you're seeing that's a reflection. The reflection of 1, 0 is 0, 1 through the line Y equals X. It's a symmetry problem. All right, not so bad. All right, let's go to number 8. And number 8, I think, is on the next page. And number 8, it says it's a tough problem. All right, it says it's a tough problem. It does. It says even a more difficult problem. Well, I'm going to go through it with you. And I'm not claiming that you're going to be able to do it completely, but I'd like to think you can. So f of x is equal to 1 minus the root of x over 1 plus root x. I'd like to write the domain down and the range down if I can. I'm not saying they're going to be easy for you. I will say this about the domain, though. The domain looks pretty easy to me. And the reason for that is, although there's a division, that division would never produce a 0. So really, I wasn't worried about those even roots. So what do I know about it? I know it's got to be, looking at it, the x has got to start at 0. Right? It has to start at 0 and then go off to infinity. The range is far more difficult. Let me scoop this over a little tiny bit. I'm going to say f inverse. No, I don't know it yet. But what I do know is I know its range, and its range is going to be 0 to infinity. All right? All right. Again, I'm not claiming this is going to be easy for you. Right? I'm claiming you can try, including you get stuck somewhere, at least someone said you tried. All right? The worst thing you can do is say, I don't want to try. I'm not going to do anything. All right? So what do? I change f of x to y. And I just rewrite the problem. Now what I'm going to do, I change, interchange roles of x and y. It doesn't look too bad. A little work, isn't it? I'll keep doing this. I'm going to move in this direction now. Multiply both sides by 1 plus root y. I'd get x plus x root y equals 1 minus root y. Oh boy, this is going to be some work, doesn't it? X root y plus root y equals 1 minus x. I'd factor out root y. Right? What do you get? X plus 1. What do you get over there? 1 minus x. So root y. Boy, this is moving along. 1 minus x. And then x plus 1, I'm going to put down 1 plus x. It looks better to me. And square both sides. And what do you get? 1 minus x over 1 plus, whoops, sorry about that, squared. All right, I can write that down now. Now, I think everyone should be able to do what I just did. I think everyone should be able to do what I just did. Everyone, all right? Now, I got to be honest with you, what everyone may not be able to do now is the range of f and the domain of f inverse. You're more difficult. There's no doubt about it, all right? I will say this, though. Looking at f inverse, I clearly know that x cannot be minus 1. I clearly know that. So how do you know that? I know that because it would be a division by 0. So I know this has something to do with the number minus 1. And this we're going to claim maybe if you could graph this guy out, maybe it would help you. Right? Maybe it could help you. All right. And certainly I'm going to say it would be nice if you could graph it out because it might help you. I got to tell you though, without graphing it, this would be a far more difficult problem for most students to do. So I'm going to claim graphing out, but graphing it out still may not be helpful. But what I do know, looking at the graph, I know it's starting at -1. And then the question is, where's it stopping? And that could be very difficult, right? Because all I know is -1 can't be in that picture. It can't be. It'd be division by 0. So I'm going to look at it, and I'm looking at the picture. This is the picture I'm looking at over here. And someone says, where's -1? I want to point it out to you. It's over here. If you look at this picture, this blue curve is asymptotic with the number -1. And I'm looking at it, and the blue curve appears to be stopping at 1. All right? So I'm going to put that down. I'm going to say it appears to be stopping at 1. Oops, sorry about that. I'll put that down for you. I'll write this over here. Okay. I want to go back and think. I will look at the key later. I want to go back and think about this though. Is it really stopping at 1? So I want to point out, if you thought about it, right? If you really thought about this and you were looking at f and you were seeing it, you'd see 1 minus root x over 1 plus root x. And you thought about it, you probably could reason through that this thing could never exceed the number 1. That's tough though. And that's why I'm going to talk about when we're dealing with SAGE, that visualizations can in fact help you understand that. But I know it's difficult. Let me go back to the key. And I want to just go back to the key with you to make sure that I've written these things down for you. And let me say, it talked about the range between -1 and 1. I see that written down. It talked about the notational inverse function, and make sure I wrote that down. 1 minus x, 1 plus x. Yep, that's written down for you. I'm seeing that. I'm seeing all the work written down, everything, and that domain range business stuff there. It's not easy. I'm not saying it is. What was not easy? Again, I want to emphasize what was not easy. Just give me a second and make sure you know what I mean. This was not easy. All right, that wasn't easy. And this wasn't easy. Why is that? It requires a good deal of thinking, and even the visualization can be confusing. All right, let me see if there's something on page number 7. No, we're good. We're good. All right. I made a mistake. I just realized it. And I'm sorry. Oh, I'm sorry. I didn't make a mistake. I'm sorry. I didn't make a mistake. -1 to 1. I thought I made a mistake. It's over here. I apologize. I thought I made a mistake. I thought I made a mistake with that that range business. No, we did okay. Okay, so here's the deal. What are you going to do now? I know it's tough. The worst bad thing about life is that, and I want to say this to you again, if you don't try, you're not going to learn the material. You have to try the problems we just presented to you here, okay? I'm hoping in life, though, when you ask someone that you're willing to try something, they're going to give you a chance. They're going to let you try. All right, thank you very much.